All right, today we're going to pull back the curtain on one of the most fundamental ideas in all of computing. It's this incredibly elegant concept that's, well, it's kind of hiding in plain sight, secretly powering so much of the tech you use every single day. You ever find yourself working on something, you make a mistake, and you just instinctively hit Control-Z? It feels like magic, right? Or when you're clicking the back button in your browser like crazy, trying to get back to a page you were just on? Well, it's not magic. It's all thanks to a beautifully simple idea. And to really get it, we don't need to start with complicated code or anything. Nope. We just need to imagine we're in a cafeteria.
I want you to picture one of those spring-loaded plate dispensers, the kind that holds a big stack of clean plates. Believe it or not, this is the perfect mental model for what we're talking about. The whole logic is right there.
Think about it, right? When a dishwasher adds a new clean plate, where does it go? Right on top. And when you need a plate, you don't try to dig down to the bottom, that'd be chaos. You just take the one that was most recently added, right off the top. All the action happens in one single place.
So, this really simple, super intuitive behavior of only ever using the top of the stack, it actually has a formal name, and it is the golden rule that governs everything we're about to talk about. And that rule is LIFO. Last in, first out. That last plate that was placed on the stack, it's guaranteed to be the very next one taken off. This one principle, LIFO, is the heart and soul of the stack.
Okay, so to make this work in the digital world, computer scientists gave these two simple actions some official but very easy names. Let's see what they are.
The action of adding a plate is called a push. You're literally pushing a new item onto the top of the stack. And taking a plate off? That's called a pop. You're just popping the top item off so you can use it. Oh, and if you just want to see what the top plate is without actually taking it, that's a peek. Push, pop, and peek. That's pretty much it.
Okay, now for the fun part. Let's connect that simple cafeteria analogy all the way back to that powerful undo feature we started with. This is where it's all going to click.
Every single time you type a word or delete a sentence or resize an image, that specific action is pushed onto a stack in the application's memory. Your work history is literally being built up, one action right on top of the other, just like those plates.
So when you hit undo, what's really happening? The program just performs a pop. It takes that very last action you did right off the top of the stack and it reverses it. See? It's not magic at all. It's just LIFO. Last in, first out. The last thing you did is always the first thing to be undone.
And the stack's versatility is just incredible. It's not just for undo. It manages how programs run, functions, it powers your browser's back button, it helps code editors check for things like mismatched parentheses, and it's even used in algorithms that solve mazes by backtracking. This one simple rule is absolutely everywhere. All right, theory is great, but let's make this really tangible. We're going to build a stack right here, step by step, so you can see exactly how push and pop really work. So, we're starting with a completely empty stack. Our first operation, we're going to push the number 10. And there it is, sitting at the bottom. Since it's the only thing in there, it's also the top of our stack.
Now, let's push the number 20. And see how it doesn't go next to the 10? No, it goes directly on top. So the top of the stack is now 20. And let's do it one more time. We push 30. Again, right on top. Our stack now has 3 elements, and 30 is the most recent one, sitting right at the top.
Okay, so here's the crucial question. What happens when we pop? Well, the rule is last in, first out. The last number we pushed was 30, so that's the first one that has to be removed. Pop. And just like that, 30 is gone, and the top of the stack is now 20. Simple, totally predictable, and really, really powerful.
So, as we wrap up here, I just want to leave you with a real sense of how important this simple idea of a stack truly is.
There's a sentiment in computer science that just perfectly captures it. A stack is one of the simplest yet most powerful data structures. In such a complex digital world, sometimes the most elegant tools are the simplest ones, and the stack is a perfect example of that. It is not an exaggeration at all to say it's a core building block for how software functions. It gives programs a short-term memory, a way to handle tasks in the right order, and a mechanism to gracefully backtrack. In a way, it allows software to think. So the next time you hit undo or click that back button, you'll know the secret. It's just a simple stack of plates doing its job. Which kind of leaves us with a final thought, right?
What other elegant, simple rules are quietly shaping the digital world all around us?